There are 4 states of the art when it comes to DevOps and automation and configuration management deployment. CF Engine, Ops Chef, AnsibleWorks, and Public Labs. First, we will start the presentation with AnsibleWorks. We'll start with Dave Johnson. Dave Johnson is the Vice President of Product. He started a career with Red Hat before they went public, ultimately building and leading the sales engineering organization that penetrated the US oil and gas, electronic design automation, and managed service provider market. Prior to joining AnsibleWorks, Dave held executive positions at RPAT, Pronto Software, leading engineering and services organization that spearheaded the transformation of innovation custom solution into repeatable products. Dave holds a Bachelor of Science in Electrical Engineering and Computer Engineering from North Carolina State University.
Thank you so much. Thank you, everyone. Appreciate being here. Appreciate the invitation. Again, my name is Dave Johnson. I'm the Vice President of Products with AnsibleWorks. I've been at AnsibleWorks since about May 1st, and my job is really to travel around and speak to our Ansible users and customers and understand what they like about that and what they don't, and help drive the direction of the product based on that data. So we spend a lot of time gathering a lot and manages our services team that travels around the world, of course, and does our implementations. Today we're going to talk about Ansible and AWS, our 2 products and 2 technologies that we deliver for innovative IT automation. AnsibleWorks was founded by Saeed Zawani and Tim Gerla and Michael Ahmed. And some of you may have heard of Michael Ahmed. Michael Ahmed is pretty famous in the open source community. Michael Ahmed was the inventor of a number of different technologies, including Khobar. Many of you have probably heard of Khobar. Khobar is a very popular open source bare metal provisioning tool. It's very popular, particularly in high performance computing space. Michael also was the co-author and co-inventor of a technology called Funk, also a very popular open source technology for distributed command line execution. And so Michael has a significant amount of expertise and experience in the realm of IT automation, particularly at very large scale, relative specifically to configuration management, to application deployment, and to provisioning large numbers of systems. And so Michael started AnsibleWorks and created Michael started AnsibleWorks and created Ansible about 2 years ago. And Ansible is a very popular today open source IT orchestration engine that's really designed for IT orchestration. And what we mean by IT orchestration is application deployment, the configuration management of the operating system and the software stack underneath those applications, and the orchestration of different tasks to deploy those applications throughout the data center, whether that be talking to network devices such as load balancers and firewalls, provisioning new systems, provisioning systems in the cloud or bare metal, deploying applications to those systems, and configuring the operating system and software stack underneath. So all of those elements are very possible and useful with Ansible. Ansible is extremely popular right now in the open source community. Ansible has more than, when I took this slide, I took these numbers a few days ago, I'm sure they've gone up since then, but Ansible has over 3,000 GitHub followers, 450 active contributors to the open source project, many of those being vendors like Intel, like Red Hat, for example, that are contributing modules specific to managing their part of the infrastructure, their part of the data center through Ansible. At any point in time, if you log on to IRC, Ansible has a very strong and powerful community. There's more than 400 people actively contributing there. And Ansible has become the most popular open source configuration management tool on GitHub today, and continues to grow in popularity. Very active community. The open source community, in fact, is our most important partner from a strategic partner perspective. The open source community, we rely on the open source community to provide and contribute modules to Ansible that enable Ansible to reach out and touch that various infrastructure, various parts of the stack. As I mentioned, Red Hat and Intel and others, we rely upon Amazon, we rely upon Rackspace, for example, to deliver and develop and deliver those modules that touch their parts of the infrastructure, their parts of the data center. And so for that reason, the open source community is our most important part. Ansible simplifies IT automation. Our real differentiator and claim to fame for Ansible is about simplicity. We believe, and our users tell us, that Ansible is one of the simplest and easiest to use IT automation technologies there is today. And in fact, Tim will certainly go into a lot of detail. He'll show you lots of demonstration, lots of examples, and you'll be able to see firsthand about really how simple this is. And so Ansible, first of all, is written in plain English, in plain language. So we write YAML to represent the actual tasks to be executed by Ansible. And Ansible uses its core Python modules and invokes those Python modules to do and effect change and do work on the managed systems. I mean, there's no agent to be installed on those systems. There's no management infrastructure to manage as part of using Ansible. And the language that we use is human readable as well as machine readable. And so it's very easy to audit the set of tasks that you're invoking to automate your IT workflow. It's very easy to pass those set of tasks to other users and allow them to audit that as well, even if they don't have any understanding necessarily of Ansible. We don't use an agent, as I mentioned, but we do leverage OpenSSH as our default transport layer, our default authentication plugin. And what that means is if your systems are running Python and OpenSSH or SSH, then they are ready to be managed by Ansible. There's very little overhead, there's very little management overhead that's required to use Ansible to manage it all. And in fact, we leverage these tools also because they fit within our brain, right? We're used to using SSH, we're used to using Python to manage our systems. And we built Ansible on top of that. Ansible is also very complete. As I said, our users leverage Ansible to do everything from application deployment to config management to the orchestration of IT tasks, even across the network layers. And part of the way that we get that complete is that Ansible ships with a number of modules, hundreds of these core modules that we ship with Ansible. And this is just a quick snapshot of these. But again, these modules primarily come from the open source community. They're curated by us at AnsibleWorks and tested, and then we deliver those as part of Ansible Core. And we have modules that cover all sorts of different tasks that you might need to accomplish through Ansible. These are just some of those. To get specific, of course, we have modules that assist with package management, so you can leverage the package manager that is built into the operating system that you wish to manage for the installation and management of software. We provide remote execution modules for actually just executing raw and arbitrary shell or arbitrary commands. And that's actually an easy way to get started with Ansible and to migrate from where you're using a lot of shell scripting, for example, or DIY, or roll your own management. If you have a lot of shell scripting around, you can roll that right into Ansible by leveraging these existing modules. You don't have to migrate everything to Ansible overnight. Other modules that provide for bringing up and down services, copying over files, templating existing configuration files, and interfacing with source code management. And Tim's going to show you a lot of this in detail. The Ansible architecture, here's a simplified diagram of how Ansible works. But Ansible, as an orchestration engine, effectively ships with that core set of modules that I showed you. And those core modules are small Python programs that actually do the work. So we transmit those modules, the ones that are necessary and required, over to the system to be managed and use those modules, run those modules on that system to effect change. Now, the end user writes what's called a playbook. And this playbook is what describes the set of tasks and invokes those modules to actually do work. And Tim will show you several examples of this as well. Again, the playbooks are written in YAML, so they're very easy to write and understand. And they interface with these particular modules to effect change. And of course, there's a number of different plugins for the transport layer and for authentication. And again, we're leveraging OpenSSH by default. The playbooks themselves, very simple. Again, we'll show you some examples of these, but the playbooks themselves, that's our terminology. Very little jargon that we use in Ansible, but that is our terminology. So the playbook contains a set of plays, and the plays execute a set of tasks. And those tasks call these modules again, and those are shipped to the system to be managed, typically via SSH and run, and they clamp after themselves. Everything in the playbook is sequentially ordered and runs in the order in which it is specified, with very few exceptions, right? So there's not, there's no confusion about the dependency ordering or the ordering of tasks and how they're going to execute. How you've written them in the playbook is how they will execute by and large. One exception to that is a special sort of task called a handler. And a handler, as you might imagine, is a special sort of task that runs when it's required. And multiple tasks might influence a handler to be run. An example of this would be a service that needs to be restarted after a configuration change has occurred. If no configuration change has occurred, the handler doesn't run. If that configuration change occurred maybe multiple times within the same playbook, I deployed an application, I changed configuration, I changed something else, that service will only be restarted once as part of that playbook, and that's the way that the handler works. Here's an example of a very, very simple playbook, and Tim is going to show you some much more complicated examples in just a few minutes. But this is a very simple playbook. Again, it's human readable. This is also what is read by Ansible to invoke change, right? This is also machine readable. This is YAML. There's very little Ansible syntax required here, but effectively you're establishing the name of the play to be run, and that's going to be communicated back to you as you're running it on the screen. So that string there is going to be human readable and let you know exactly where you're at in the playbook and which task you're executing. I'm limiting this particular playbook to, or rather I'm not limiting across hosts, I'm executing across all of my hosts. But that host line enables me to limit according to specific hosts or specific groups of hosts. And I'll show you how that inventory can be sliced and diced into those groups. The tasks below are the tasks that are being executed by this playbook, and in this very simple case, we're simply installing Apache. We're installing the latest, so we're calling the yum module there, as you can see, and we're telling the yum module to install the package HTTPD, and we're asking for that package to be installed at the latest version. So there's a few different a few different language syntax pieces you can use here to specify a specific version of a package, or the latest version, or what have you. And you don't need to know that specific version here. And then, of course, all we're doing is starting the service and making sure that the service is started after this playbook. And again, so we're calling the service module. We're telling that we want the HTTPD service in particular to be running at the end of this playbook. So this playbook, of course, is idempotent, right? And idempotency means that I can execute this playbook over and over and over again and expect to get the same result, right? And what I mean by that in more detail is, if I ran this playbook and HTTPD was already installed with the latest and was already running, then nothing would happen. There would be no change, right? But I can safely execute this playbook over and over again, and nothing detrimental would occur to the system at all. However, if HTTPD was installed at an earlier version and it was running, that would be upgraded. If it was at the latest version but not running, it would be start, right? And I could continue to execute this playbook in that way. Very simple task. Now I'm executing these playbooks against a set of inventory. Inventory in Ansible is generally specified in a set of inventory files. They're very simple. You can certainly manually manage those files, but more commonly, our users generate these files automatically, generate inventory from some external source. And that external, I'll talk in more detail about that. This is simply what the file looks like. It's a JSON representation. I have listed out my host name here, the specific systems that I wish to manage my inventory. That could be done by host name, it could be done by IP address, it could be done by alias, right? And you can see that I've grouped these servers, these systems, into a web group and a database group. And I can arbitrarily group systems any way that I wish based on those very simple labels. Going back to our playbook execution, right, I can specify the name or host's web, for example, to limit the run of this playbook against the web servers and not even look at the database servers, for example. Now, right now, Ansible supports a number of ways to automatically generate the inventory. Again, the inventory file itself is just a JSON representation, so you can use custom scripts, you can use existing programs that you have to interface with your own custom configuration management database or your own source of hosts and develop and create these files and continue to update them dynamically. We also provide built-in integrations with cloud providers, public cloud providers, private cloud providers, and of course in the bare metal case with Khobar as well. So if you're using Khobar in a high performance compute cluster, you can use Khobar to actually generate your inventory file and feed that to Ansible. Now, I've talked a lot about Ansible. AnsibleWorks also provides a commercial product that we call AWX. So Ansible is pure open source, 100% pure open source, and AWX is a commercial proprietary product that fits on top of or beside Ansible. It is not a commercial version of Ansible or an enterprise version of Ansible or anything like that. Ansible itself is 100% pure open source and full featured. AWX provides a web-based user interface to Ansible and an API endpoint. And AWX provides some of those nice features that you like to have when you have multiple people in your organization using Ansible in a collaborative, team-based way. Right, so once it's more than one person using Ansible, then something like AWX is what you want to look for the purposes of managing, source code management of playbooks, managing authentication of all of the different users that are using AWX, managing the inventory as we described, and providing an easy way to share playbooks and delegate responsibility amongst members of your team. AWX provides for a couple of screenshots there, but AWX provides for push button automation, right? So yes, many users use Ansible on the command line. It's very powerful, very full featured. But if you want to give that capability of Ansible to, say, QA downstream or upstream to developers, to people who don't know about Ansible and don't necessarily care about those tools underneath, then you can provide this web-based UI and give them push-button access to leverage Ansible to deploy applications, to manage configuration, to invoke change in your data center. And so AWX sits on top of Ansible and provides that push-button automation. Now that's all powered behind role-based access control. So there's full-featured permission-based systems inside this UI. And that allows you to specifically restrict which user can execute which Ansible playbooks against what sort of inventory, right? So you can give as much as or as little of control of Ansible over to your users. AWX has some features for auto-scaling, which means that instead of invoking Ansible and affecting change on deployed systems, I can let those systems come up and ask Ansible to be configured. So systems that come up as you're provisioning systems, perhaps in a HPC cluster or in the cloud, as those systems come up, they can reach back to Ansible through AWX, through the API, through the callback feature, and say, I should be configured as the X or Z, as a web server, as a database server, as this particular application. And that's all done by token-based control. And AWX also provides our full API endpoint. So there's a full RESTful API for AWX. Everything that you can do through AWX through the web-based UI, to pointing and clicking, can be done through the API as well. And so if you want API access to Ansible, the best way to get there is through AWX. And that gives you all the capability to write your own custom integrations, to invoke Ansible from a continuous integration or continuous deployment system, and also integrate AWX and Ansible upstream with your environment as well. I'm going to wrap up with just a few of our users, and as long as we have time, we're happy to talk in great detail about our users and their use cases and what folks are doing with Ansible and AWX. But this is our obligatory customer logo slide. And I'll talk about a few of these in particular. Of course, we've got Red Hat up here as well. Red Hat's using Ansible extensively in the OpenShift side of their business, as well as Fedora. The Fedora project uses Ansible exclusively for the deployment of their particular infrastructure for the testing and development of that distribution. Of course, Rackspace is here as well. Rackspace is one of our big users, also, of course, a big user of Puppet and other technologies. And Rackspace uses us primarily to manage the public cloud side of their business. So certainly Rackspace pushes the scale envelope with the technologies that they use, being that there are such a very large large scale. And so Rackspace has been using Ansible pretty extensively and contributing a lot to Ansible as well. So Rackspace has written the Rackspace modules for Ansible that allow Ansible users to interface with the Rackspace public and private cloud technologies. Bank is a very large, trading firm in Amsterdam that is making extensive use on Ansible, actually on traditional bare metal and Unix environments as well. Axial Corporation is a smaller trading firm over on Wall Street, and then of course Drilling Info. Drilling Info is one of our newer customers. Drilling Info is actually a new software as a service company in the oil and gas space as well. They're based out of Texas, and they're developing software for oil and gas exploration that they provide as a service to other oil and gas companies. They are small but growing pretty quickly and are using Ansible to deploy their entire application stack. And that's the pretty common use case for Ansible. Although many users use Ansible for strict configuration management of the operating system or middleware, most of our users, the sweet spot for Ansible is application deployment on top of that configuration management as well. And so many users are using Ansible to actually deploy their application, make those configuration management changes underneath, but keep the business operating by deploying that application. And that is the case certainly for Drilling Info. At this time, I'd like to turn it over to Tim Gerla. He's going to come up here. He's going to walk us through some extensive demonstration and show us really how Ansible works from a technical perspective. And then we'll be happy to take lots of questions. Thank you.
Hi, everyone. Thanks for having us today. And as Dave mentioned, I'm going to go into a little bit more technical depth here and talk a little bit about some of the use cases for Ansible and how those are accomplished. I want to talk a little bit about the cycle of what Ansible does and how it interacts with your systems. There are different ways to look at this, and of course different applications work in different ways. But Ansible handles configuration of initially deployed systems to application deployment and then higher level orchestration of multi-tier applications. Think of a web application with a load balancer and a monitoring system, and then you've got your web servers and your app servers. How do you efficiently manage those systems in a coordinated way? That's something Ansible is pretty good at doing. We can move on from orchestration to updates of applications, similar to the initial deployment, but there could be other steps, including data migrations and so on. And then compliance, and this is, depending on how you implement a compliance mechanism, you can use it to ensure configuration consistency across multiple systems. You can remediate the configuration if necessary, make changes to make the system conform, or just report on the configurations and what may need to be changed. Talking about configuration management, Dave certainly touched on this. You've got your declared state in your playbooks that describes how your systems should be configured, and then Ansible, in combination with the playbooks and the modules and the inventory, make it so. And Ansible can report whether or not those systems are in compliance. And application deployment is somewhat similar, although configuration management is usually a declarative mechanism where you say, this is the way I want my system to be, and Ansible will make it so. And I'm just going to adjust my mic to see if I can lessen the feedback a little bit. And the application deployment can often be just more of a series of tasks that run in sequence. And in Ansible, you can model either the declared state or just a sequence of steps pretty easily. I'll show you some of that. Dave talked about this. I'm not going to go into great detail, but again, Ansible is intended to be simple, and we think that we've really kept the language fairly simple, easy to read, easy to write, easy perhaps even for non-technical people to look at a playbook and understand what's going on. Security is a big aspect of Ansible. We use OpenSSH by default. No custom security infrastructure needs to be put in place, so if you already have SSH, you can begin managing those systems immediately with Ansible. And the fact that there's no agents involved means there's less attack surface for the machines that are under management. And of course, we handle everything from configuration management all the way to task orchestration. Okay, so enough slides. I'm going to do a couple of demos here. The first one will be to deploy OpenStack on my laptop. OpenStack is a pretty tricky technology to deploy. We've written some basic playbooks to deploy OpenStack on a set of systems, and I'm not actually going to do a live deployment now because on the hotel Wi-Fi it takes about 20-30 minutes, which would be most of my presentation. But what I'm going to do is show you what it would look like. And if I can get to my web browser here. I'm going to show you AWX. This is the web interface that sits on top of Ansible. It's not necessary for use. If you just want to run playbooks and manage your inventory, you can use the open source tools effectively. And I'll show you some of the playbooks, but I'll also show you what AWX looks like. It's a web application. It runs in your environment, and it gives you basically push-button access to the playbooks. We have multi-user access control here, which lets you delegate authority to users to do certain things. You can organize those users into teams. Ansible can manage the SSH credentials for connecting to your machines, to connect to the cloud environments, to connect to source control here. And as you can see, I have a handful of credentials here. These are usually SSH keys, but they can be passwords as well. If you look at one of these here, you see I've specified an SSH username. One important key to the credential management is that once you put a credential into the system, into the database, users can't take it out. It's secure in the database. It can be used by users if they're given the permission, but it's saved there securely and encrypted. So you can configure a whole bunch of stuff here in the credential. And then you have projects. Projects are basically collections of playbooks, usually stored in source control. Most of our customers are using Git, but we support Git, Mercurial, and Subversion. And if you just need to put the playbooks on the disk that's running AWX, you can do that as well. So I've got a handful of projects here. And then the inventory. The inventory is an important topic in Ansible. These are the hosts under management. And as Dave mentioned, these can come just from a flat file in groups, or you can actually pull the inventory from a cloud platform, from OpenStack, from Amazon, from Rackspace, and so on and so forth. And if we look at one of these inventories, we can see it's a list of groups, database servers, load balancers, monitoring web servers. I have only one inventory, one host in this inventory actually. And one of the things we've tried to do in this interface is really push information about failures or about successes of various jobs throughout the system so you can see at a glance what succeeded and what may have failed. Okay, so once you have your credentials, you have your projects, which are the playbooks, and then you have your inventories, you can assemble a job template. And a job template is basically a way to run a playbook with one click. So let's take a look at the OpenStack deployment here. So there's two kinds of playbooks, or two kinds of ways to run a playbook. You can run it in the regular run mode or in the check mode. And the check mode is like a dry run, which will not make any changes to the target systems, but it will report on what it would change. So this is useful for configuring, for compliance management, for doing a report of if the system is in compliance with the configuration which you've specified. For this job template, I'm going to stick to the regular run. I've chosen my inventory, I've chosen my project, and then from the list of playbooks within that project, I've chosen the site deployment playbook, and most projects have a handful of playbooks. You might have one to do the initial deployment, you might have one to do an upgrade, you might have one to do a backup, and so on. I've chosen my credential, and there's a bunch of other options that you can specify, although I don't need to do that here. So if I go back to the list of job templates, I can go ahead and launch this job, and this will kick off a playbook run. I've already run this playbook so that to set up the system beforehand, but this is going to go through and run through every task and make sure that the system is in the configuration that we specify. So what do these playbooks actually look like? Let's take a look at one of the examples here. This is part of the OpenStack deployment, and hopefully that's somewhat readable on the screen there. As you can see, this particular playbook doesn't do much. It has several plays that target different hosts. So what this is actually doing is this is kind of grouping your systems into roles, and then applying a role to the systems in your inventory. And if we go in and we look at this common role, for instance, we can actually see what these tasks look like. Let's fix the syntax highlighting here. So this is a more complicated example of the playbook that Dave showed. Really, it's just a step-by-step list of tasks, a list of declared states, so to speak. For instance, you can see here we have a list of packages that need to be installed on the system. And Ansible will go to that system, it'll run this command, and the module responsible for this task, the yum module, will check to see, okay, do we need to install these packages? If so, it'll make the changes necessary and report back to the user. If no changes need to be made, it'll report back that no changes were made, as you might expect. And here we're actually notifying a service to be restarted. And in fact, this is restarting multiple services. This is one of the more complicated playbooks out there. OpenStack is fairly difficult to deploy, so there's a lot of different steps here, but most playbooks are going to be simpler and shorter. You can see a whole bunch of tasks here. We're copying files to the target system. We're running some shell commands to do package builds. This is a little bit unusual. Usually we just install packages, we don't build packages, but in this case we had to. Setting the host name, rendering templates to the target system. So a whole range of things is going on here to make this deployment happen. Again, for the compute nodes, the list of tasks is a little shorter, but we're still installing packages, we're copying files, we're doing all these things that you would ordinarily do by hand or in a shell script and putting them in this playbook. So let's go back to the web browser and take a look at this job here. So the job is running, and we can see the output here of the playbook run. This is going to take a long time because it's doing queries to Yum repositories and so on, and the hotel Wi-Fi is kind of slow. It takes about 20 minutes normally to deploy OpenStack. There's different ways to view this information. If you've ever used Ansible before, you'll recognize this output, but you can also view a summary of the system once it's done, and I'll show you an example of that. You can also see on a very fine-grained basis, task by task, what happened, was it successful, did something change, which host was targeted, and so on. So several different ways to view this data. Let's go back to the jobs list and take a look at a previously failed job, because those are usually the most interesting. It's not that interesting if something fully succeeds. But if you look at a failure here, you can click on the job ID, and you can go to the summary. And I only have 2 hosts in this list. This is all running on my laptop on virtual machines. But you can see that one of the machines succeeded in all of its tasks. There were 16 successful tasks, 3 actually changed something on the system, 5 were skipped for whatever reason. But on the control, it looks like we had 1 failure. So when you have 1,000 hosts or 2,000 hosts or 5,000 hosts, it can be really useful to be able to drill down into this list and see exactly what happened. And even more so, if you go to the inventory view, you can query in certain ways to say, show me only the failed hosts and figure out what went wrong. So if we click on the failure here, We can see all of the success, all the successful tasks, and we can drill in and figure out, what went wrong with this particular playbook run. And I don't remember exactly why this failed, but we should be able to find out why. So it looks like my Wi-Fi went down. We lost connection to the repository, so that's why the playbook failed. So anyway, some hopefully useful tools here to let you drill in and figure out why things failed. And Ansible itself has some interesting capabilities with respect to failure. If you're managing a lot of similar systems, you can define a failure threshold and say, I want my entire playbook job to fail if 5% of the deployments fail. But if it's only 4%, then continue on. You can have individual tasks that are able to report an error, but you continue on. So you have some ways to, when you're writing the playbook, define what is actually a critical failure and what's just expected. Say you're deploying to a cloud, Amazon, when you bring up 1,000 hosts, maybe a few of them won't actually come up and be ready for management, but you want to be resilient to that and handle it. Okay, so that's one example of kind of an initial system configuration. And in the end, you should get a running OpenStack implementation. It's not ready for production yet. Our playbooks actually group all of the OpenStack components on a single server. So for production purposes, I wouldn't recommend it, but it could be a good starting point if you're interested in deploying something like OpenStack. Let's talk a little bit about the web application deployments and application deployments instead. I've done something similar with a very simple web application. It doesn't do anything except print something on the screen. But if we look at the web app inventory and take a look at the hosts, this again has been previously deployed, and it's just a simple web application. Doesn't do anything except print some things on the screen. This is actually part of a full stack that includes a load balancer, includes the Nagios monitoring, database server, and then as many web servers as you need to define. It's one of the really good examples if you're interested in learning Ansible. It's called lamp_HA proxy, and you can find that in our documentation. So this is a simple web application that's deployed by Ansible. The playbook looks similar to the OpenStack playbook. It's a little bit longer actually because there's more classes of servers. You have all of the hosts that have the common configuration applied. You have the database servers that have the database configuration applied. Web servers have web and Apache. Load balancers have HA proxy. And monitoring has Nagios, as you might expect. And the playbooks underneath here will look similar. They will, copy files, they'll render templates, they'll install packages, all that basic stuff. What gets a little more interesting is when you go to do an upgrade to these systems. So let's actually do that right now. I'm going to go to my job templates, and I'm going to set up the rolling upgrade here. So this is another job template that has an inventory selected. It has a playbook, the rolling updated playbook selected. And what I can do here, there's a variable within my playbook that defines the application version that I'm deploying. And the version is just it's a checksum from the Git repository. And I'm just going to go ahead and override that variable and give me the latest application here. So I've saved a change to that job template. I'm going to go ahead and launch that now. And what this is going to do, if this were a real production server, I would have a load balancer, I'd have several web servers at least. And if we go to this playbook, and it's going to be a little tough to read on the screen here, but hopefully not too bad. There's some front matter and some comments and so on. But you can see there's a play that targets the web servers, and we specify serial 1. What does this mean? This means run these tasks one server at a time. If you had 5 web servers, you wouldn't want to take all 5 of them down. The apply the update because you may actually have downtime for your users. What this can do, this can actually do the updates in series and first configure one server, takes the first web server in the list, it goes out to the Nagios server using the Nagios module and disables alerts for that web server, moves on and disables the server in the load balancing pool. And then what we do here is we actually just reapply the roles that have already been written to deploy and configure those servers. So if there are security upgrades that need to be applied, if there are configuration changes, that will happen in addition to upgrading the web application that you're looking at. So this particular web role is the one that deploys the application. After that deployment has happened for that web server, we'll go ahead and undo the things that we did in the beginning. So we'll go ahead and put this server back in the load balancing pool, and we'll re-enable the Nagios alerts. One thing you could do here is run a test and say, okay, after we've applied the update, let's test this server, make sure it actually works before we put it back in the load balancing pool. So you could do something as simple as, make sure that the web server is still listening on the port that you expect, or you could actually do something more sophisticated and automate maybe log in as a user and run some test. And assuming all those things passed, you could go ahead and continue on and deploy the update to the rest of the servers. The last thing you want to do in an automation environment like this is roll a broken upgrade out to 1,000 servers and then have 1,000 broken servers. So the more you can do to put safeguards in place to prevent that, the better. So let's take a look at our rolling upgrade task. Oh no, it failed. Let's see what happened. Let's see, authentication. Let's take a look at this here. I think I may have chosen the wrong credential. Yep. One thing that might be interesting to people here, if you've heard of Vagrant, it works really well with Ansible. It's a virtual machine management tool, and there's some Ansible integration where you can spin up a VM based on your specifications and then provision with Ansible. I use it all the time on my laptop for testing, for bringing up new VMs, for configuring VMs. Really a good and useful tool. All right, so I've started that job over again. While that runs, let me show you a couple more things. Dave mentioned the API that we have in place, and what we have in AWS is actually a browser for the API. So if you're writing applications to use the API, this can be useful, as opposed to just reading the documentation. You can actually dynamically query the API and the possibilities here. And as I go in, if I hit something that needs authentication, I can go ahead and do that here. And you can see in JSON format all the records in the database. You can actually post updates to these records as well. So this can be really useful for testing and building your own applications. And our job failed again. Okay, let me try something else. I'm going to go ahead and override the variable here. And go ahead and do a full deployment. This shouldn't take long because I'm only operating on one host. Let me go in while that runs and show you one more thing. Let's see. So this is the code that actually, or the playbook that actually deploys the web application. And what a lot of people do in a continuous integration and continuous deployment environment is deploy directly their application from source control. So there are modules in place in Ansible to pull from source control, to deploy to the target system. There are modules for Git, Subversion, Mercurial, and perhaps others. And it's a good way to deploy your applications if they don't need to be built, compiled. A lot of people are using a tool like Jenkins or Bamboo in their continuous integration pipeline to do the builds of an application and then give that build to Ansible to do the deployment. So there's definitely different ways to handle this. But this is just a little bit more advanced example of a task to deploy from a repository. And the curly braces here mean variables. So you may have seen me type in an override for the web app version variable. That gets substituted into all these playbook task lines. Okay, well, it wouldn't be a live demo without a failure. But what I wanted to show you is this actually being updated. I do seem to have some credential problems here. Just try one more thing. I'm pretty sure that's the credential I need. I have too many VMs running on my laptop, I think is the problem. All right, let's see if the third time's the charm. Any questions right now that I can address while this runs? Yes?
Speak about the tools for VM. You mentioned something about tools that help you to do stuff in VM. Can you give us more share, please?
Sure. The tools that I'm using to manage my virtual machines, at least on my laptop, I use Vagrant and VirtualBox. Vagrant is, I'll show you an example here. Vagrant is a mechanism by which you can define a set of virtual machines with parameters, and then let's just change the syntax here so it's a little easier to see. And so you start with a certain pre-built image, and there's lots of these images. There's some percentiles, there's Ubuntu images. You can define networks here, and then you can actually call Ansible directly from this Vagrant configuration. And it's really just a matter of running a command like Vagrant up or Vagrant destroy or Vagrant provision. And it basically handles all the VM creation and configuration and destruction when you're done with it. So really works well for development. Some of our customers are using Vagrant as well as a way to very quickly and easily stand up standardized development environments for their engineers. It's not really a production tool. It's more of a development tool on personal workstations or something like that. Very good, very popular tool, almost as popular as Ansible. Maybe more popular, I'm not sure. Okay, I'm gonna try one thing. Any more questions? Yes?
I was wondering with the dependency for the Ansible on the SSH and Python, how would you handle the, from a security perspective for these packages of security itself, SSH, if there's the bug fixes or some kind of security risk in these packages? Because they are core.
Sure. Yeah, so the packages that are required on the target systems, SSH and Python, are usually the basic packages necessary. What you can do and what most people do is set up in their playbook a common role that applies to all the systems. And in that common role, you can actually require certain versions of these packages to be installed. So you do have to be aware, you can actually ask for the latest versions to be installed as well. So depending on your requirements within your organization, you can say, this is my list of exact packages that need to be installed, or just give me the latest from my repository, and then run that playbook periodically to keep those systems up to date. What some people do in larger environments is actually run their own custom repository of packages for their OS, and keep that repository up to date with the packages that they need to have installed, and then simply make sure that all the systems periodically are updated to the latest versions. Does that help?
Well, is the only way for basically managing the environment through SSH, or if you can do certificates, or is it only just SSH is the available method of updating?
Sure, good question. The question was, is SSH the only mechanism of connection to the target systems? And the answer is no. The default is SSH, but there's other mechanisms as well. One of the ones that is popular in large-scale infrastructure, for instance, Rackspace is using this. There's the accelerated mode, which actually makes the first connection with SSH and bootstraps a small listener. It's actually a small agent that runs for a period of time. And it's about 10 times faster than SSH. So if you're sending a lot of commands out very quickly to a lot of hosts, you may run into a situation where the connection of the SSH connection adds some overhead. Beyond that, there's been contributions for connection to Cisco devices. I think it's basically a telnet style connection, but it's specific to Cisco. And if you have an unusual device, you can actually write your own connection plugins to talk in different APIs or different protocols. Yes.
Hi, Tim. Is it Tim?
Yes.
Just a question about your solution. Have you had any clients use your solution with the GPFS storage environment cluster? The only difference is because you talked about the web servers and how they fail one at a time, and you reverse you undo what you did. Now, and the only difference is in the GPFS environment. I have the multiple nodes, and they have different roles. They have metadata managers, they have the GPFS cluster manager. And how does your client manage failing over these tasks without impacting the, like it's in a case of upgrade, for example?
Right. The answer to that depends somewhat on the application, and I'm not familiar enough with GFS to give you an exact answer how that would be implemented with Ansible. But depending on which things can be taken down at which time, you can write your playbook in such a way that it does that in the right sequence. I would definitely want to dig in a little bit more and learn more about GFS before I give you an answer.
Are there any Ansible modules for GPFS or for any of that specifically? It may make sense that there would be instead of
writing a playbook specifically for that, and a lot of times vendors or community contributors provide a module to affect that, and you can write the playbook and that's fine.
Oh, I'm just interested if somebody already has.
It's quite possible. Tim generally would know if they did.
I'm not aware of any.
That's good.
But there's a lot of modules I'm not aware of. So. Okay.
Any other questions?
Lee?
Just a clarification, because I know JPFS, I know Ansible. So what you are looking for is you are looking for what Tim was describing as a rolling update. And we need to use roles. So basically you define your infrastructure, be it storage, be it network, be it systems, in terms of roles. So you have one role as a metadata server, you have another role as basically a compute node, and you have another role, whatever it is. Okay? And if and NFS, for example, yes, NFS client, NFS GBFS client. And let's say the metadata is critical, so you should have at least 5 or 10 up. Okay? So you serialize that you don't upgrade or you don't do any operations on the metadata servers. Okay? You can serialize them to 1, which is the minimum. I don't think there's a minimum other than 1. Okay, so basically you will do 1 update at a time. Or if you know that you have 10 servers, you can serialize up to, let's say, 9. So so what you are looking for is the roles with the rolling update.
My
question was, are you limited in the playbook, for example? Are you limited to the commands defined by the playbook syntax, or you can use the system commands?
Yes, good question. Okay, so the question was, can you issue arbitrary commands to the system without using an Ansible module? There's several modules to do this. There's the command module, which just sends a command. There's a shell module that sends a shell command, so you can use pipes and redirections and so on. So yes, you can issue arbitrary commands very easily. In fact, that's what we do to configure HA proxy. We just send a command to HA proxy just on the command line. So that's definitely possible. In a lot of cases, it's useful to build a custom or a specific module for those operations, but sometimes you just want to run a command and have it be done. So that's very common. Very common. I think I might be out of time now.
Yes. Thank you so much for AnsibleWorks for the day. We will break now for a final and lunch break for 15 minutes, and we will come back for Puppet Labs.